Let me check. What is it saying? How do I do this? I think it's okay now. Okay. Okay, so everything is set. Let me share the screen. Share screen. Just to confirm, can you see my screen?
No, I can't.
Oh, you can't?
Oh, now I can hear you.
Oh, so you
No,
can't
now
see
I
the...
think I can. App.
Okay.
Yeah.
Okay. So this is what do you call this? Introduction to... Hope this thing works now. Should work. Okay, it's okay. So this is introduction to random variables. So I feel like before we start doing any questions, we should just try to explain a bit on what random variables are, and just to point out a few considerations that we're supposed to make whenever we are dealing with random variable. So for random variables, isn't it? We have two types of random variables. The first one, we have discrete. Then the second one is continuous, isn't it? So an example of a discrete random variable is, what can we say, on something that's countable or that has exact numbers. Let's assume, what say, no, actually, let's start with continuous. With continuous, I know we have weight. Weight is a continuous variable. Then for discrete, let's say number of people, maybe in a class. So what discrete means is it literally means that whatever people, or sorry, whatever computation that you are going to make will get exact values. The exact values, I mean, like, let's assume you're counting the number of people within a confined space. You can only have 1, 2, 3, 4, 5, etc. number of people. Like, there's no way that you can have 1.3 people, you see. So this is literally the aspect of a variable being discrete. Then for continuous, it can have those intermediate values. Like for weight, someone can weigh 40 kgs, someone can say 45.3 kgs, etc. Or even height also. Height is a continuous random variable. So that's what it means. So knowing now the two types, isn't it? One thing that you also have to know is the way that you deal with these variables is different depending on the variable that you're dealing with. So let's start with discrete, because that is the first, isn't it? So for discrete, I feel like by now you already know the probability distribution table, like that table where you have x, isn't it? Then you have probability of x is equal to x. This is what I mean by probability table, isn't it? So within this probability table, one thing, or actually before we we look onto this, before we look onto this, one thing you also have to know is whenever you're dealing with discrete random variables, the function that is used to model this is called a probability mass function, like it's called a PMF. But when you're dealing with continuous, like with continuous, it's called a PDF, like you see as you go. So with the probability mass function, here I'm explaining the properties of a PMF, which is used to model discrete random variables, isn't it? Let's assume here for x we have 1, 2, 3, etc. Then probability of x is equals to x. Let's say we have A, B, and C, isn't it? So amongst the properties of a PMF, one thing you have to know is summation of all probabilities is always equal to 1. Please keep note of this property. Like when you add all these probabilities, some of them is supposed to be 1. It doesn't change. See? That's 1. Then for 2, we know that E of x is equal to x times probability of x is equals to x, isn't it? So on the basis of these two properties that we just gave here, what it means is like with respect to 0.1, we say the probability, let's say 0.1, we said probability of x is equals to x is equal to 1, isn't it? So what it means is A plus B plus C is equal to 1. This is what 0.1 means. Then 0.2, where we said E of x is equal to x times probability of x is equal to x, where this means now that's going to be 1 into A plus 2 into B plus 3 into C. This is E of x. Then 0.3, we're working out the variance. Like these are the most important properties that you'll be asked, like the E of x, the expectation, and the variance. So for the variance, power of x is equal to E of x squared minus E of x this squared. Keep in mind, these two terms are different, isn't it? And also, before we look onto variance, E of x can be referred to as the mean, expected value, etc. I forgot the other terms. So whenever the question tells you that the mean is whatsoever value, then you know that they are literally talking about the expectation, which is E of x. See? So they might tell you that the mean is, the average is, the expected value is. So whenever they say that, you should already know that you are talking about the expectation of the random variable x. So v of x is given as this, where E of x squared, in our case, it's going to be 1 squared into A plus 2 squared into B plus 3 squared to C. This is E of x squared. So v of x is going to be that, where E of x squared, you already know what E of x is, isn't it? Which is what you'd have calculated here. So it's just going to be A plus 2B plus 3C squared. So your variance is going to be the difference between these two values. Like you say this minus that. This is the operation. So that's how you deal with discrete random variables. So now let's assume you're working with continuous, isn't it? So for continuous now, it's more or less of a different case, because for a continuous, you are not given a probability mass function, but you are given a probability density function. So whenever they tell you that the function that you're dealing with is a probability mass function, then you should know that you're dealing with discrete. And now when it's a density function, you know that you're dealing with that, with continuous. So what are the properties of a PDF? It's actually the same, isn't it? But now, instead of doing separate sums as we did here, like isn't it, we are saying probability of X, summation of all probabilities is equal to 1, isn't it? For continuous, I think if you can remember from your calculus, summation is more or less the same as integration. So what it means now is instead of summing the individual parts, you deal with integration of all X values. So the integral of the function, like this function of X, is actually the PDF that we're talking about. With respect to X, should always be equal to 1. If not of this property, we'll use it. Yes, we proceed. You see? So this is the first property. Then the second, when I'm looking for the expectation of X, it's going to be the integral of all X values, you see, of X into function of X dx is equal to 1. This is the other property. So what it means is for any what do you call this? For any probability density function that you are given, you multiply it by X, then you integrate within the limits that you are told, which you will be told actually, and the answer that you get will be the expectation of that function. So this is for E of X. Then for var of X, it's actually the same also. It's going to be integral of X squared into function of X dx for all X here. Then minus E of X, which is what we just found here, which is integral of X function of X dx, this squared. This is all X. So as you can see, it's literally the same concept, but now we are just dealing with integrals only. So if you're dealing with the integrals, that's how you go about it. So I feel like with this, also, yeah.
You said for variance we just subtract EX.
Yeah, we subtract E of X squared.
Oh, okay. Thank you.
Okay. So with this, you know that you are done. So let's go on to, because keep in mind of everything that you just said now. Like you see as we go about the questions. And I feel like we actually have time to go through maybe all of them if possible. The only problem is I'm not feeling well, but we can try. So you have the document, isn't it? So let's say question, isn't it? They're calling it question breakdown. Question breakdown. So for question breakdown, we are looking at question 1.3 in that document that I sent. So question 1.3 is saying a random variable X is the following probability mass function. So I told you the moment they say it's a PMF, then you know very well that you're dealing with what? With discrete values. It's a discrete random variable. That's one thing you know now. And they're saying a function of X is equals to probability of X is equal to X, which is equals to K into the modulus of 1 minus X, where X takes values of -1, 0, and 4. You see, then they are saying the expected value of X is. So one thing that I would recommend you do whenever you are given a PMF is you draw that probability distribution table. So you have X, isn't it? The values that you have. Then you have probability of X is equals to X. Then what values can X take? X can take 3 values, -1, as 0 and 4. These are the values that x can take. Then what are the probabilities associated with this now? We don't know because we're given the probabilities as a function, you see. So let's substitute the values, the respective values of x into the function, isn't it? So our function here is saying k into the modulus of 1 minus x. This is our function, isn't it? So let's assume, or actually let's just call it function of x. This is equals to what? Function of x. So function of x is equals to k into the modulus of 1 minus x. So what is the function of negative 1? It's going to be k into 1 minus 1, which is going to be 2k, isn't it? This is for function of negative 1. So what is the function of 0? Function of 0 is going to be k into 1 minus 0, which is k into 1, which is k, isn't it? This is function of 0. Then what is function of 4? Function of 4 is going to be k into 1 minus, what's our x? It's 4. So it's going to be k into the modulus of negative 3. So we know that the modulus of negative 3 is just going to be what? Equal to 3k. So now we know the respective probabilities that are associated with those x values. Now we come back and fill in this table. We know that when x is equals to negative 1, what's our probability? It's 2k. For when x is equals to 0, your probability is k. For when x is equals to 4, your probability is what? 3k. So knowing this, we are done. And the question is saying, what is the expected value? How do you calculate the expected value? We already said that E of x is going to be x into probability. Our x values is going to be negative 1 times what? Times k, then plus 0 times, it's negative 1 times 2k, sorry, then 0 times k plus 4 into what? 3k. Then it's going to be negative 2k plus 0 plus 12k, which is going to be equal to what? To 10.
Excuse me.
Yeah.
Why where you have x before the probability, like in the blue, this ex is equals to xp, yeah. Where's this x coming from, the first one before the probability?
Or is these values that x is taking, these values within the table, these ones.
Oh, okay.
Yeah. These are the values that we use.
Okay.
Okay. So our answer here is going to be 10k. But what is the value of k now? Because you just can't say it's 10k. So we go on to that first condition where we say the probability, like, sorry, that first condition we said summation of probability of x is equals to x is always equal to 1, isn't it? So if we sum up all these probabilities, we have 2k plus k plus 3k within our table is obviously equal to 1. So 3 plus 1 plus 2 is going to be 6k is equals to 1. So the value of k is going to be 1 over 6. Then if k is equals to 1 over 6, of which we had already established that our E of x is going to be 10k, which is going to be 10 times 1 over 6, which is 10 divided by 1 over 6, that's 2 for 6, 8, 10, which is 5 over 3, which is 1.66 recurring, or just 1.67 as he gave the answer. So this is how you work out this question. Like, do you have any questions before we move on?
Okay, just a recap. So firstly, we draw the table and then fill in the x values.
Yeah.
And then we take the function and substitute the x values to get the p values.
Yes.
And then once you have the x values and p values, you calculate ex.
I feel like in this case, isn't it? The best thing that you can do is to first incorporate the condition in order to determine what the constant is. I feel like that's the best method to start with, rather than what I did. Yeah.
Okay.
Yeah. Okay.
Hi.
Hello.
So we have to equate the whole thing to 1.
Yes,
Not
the
zero.
summation of the probabilities.
Oh, okay. Why 1?
Because the ranges of all probabilities is between 0 and 1. So the maximum probability that you can get is 1.
Okay, so why pick 1? Why not start with the 0 and then end with 1? Why do we specifically have to pick 1?
Because 1 is the maximum. Because
Okay.
we'll be dealing with the maximum here.
Okay.
Yeah. I feel like you will see when we are dealing with the continuous, where what you are saying will will apply, I think. Okay, now let's move on to let's not move on to question 2.6. We'll do it later. Let's move on to question 3.2, because I just want to do questions that are associated with this first, then we'll move on to the other aspect. So question 3.2 is saying a random variable x has the following probability mass function. If it's a mass function, you know that it's a what? It's what do you call this? It's discrete. And if it's discrete, you have to draw the probability table, which we already have. In this case, it's x, probability of x equal to x. Then with this, we have -2, 0, and 4. Then the probability is going to be beta, 2 beta, and 1/4. Then the variance of x is. So first step, like we want to calculate the variance of x. How would you calculate variance of x? It's going to be e of x squared minus e of x, everything squared. This is how we calculate the variance. And so this is question 3.2. Okay, so with this now, isn't it I told you that the first step that you're always supposed to take is to determine the constants, isn't it? So with this, how can you determine the constants? We know the summation of probability of x is equal to x is always equal to 1. So it's going to be beta plus 2 beta plus 1/4 is equal to 1. So we have 3 beta is equals to 1 minus 1/4. Then 3 beta, it's going to be 3/4. So beta is going to be 1/4. So knowing that beta is 1/4, you can just come in and substitute the values in the table. So in the table, we know here it's saying beta, isn't it? Here it's 2 beta. So for beta, it's going to be 1/4. Then 2 beta is 2 times 1/4, which is 1/2. So with this, you know that you are actually done. Now you calculate the components that are required in order for you to determine the variance. So what's E of x? E of x, we said it's x times probability of x is equals to x. So for x, for our first x value, we have -2 times the probability, it's 1/4, then plus 0 times 1/2 plus 4 times 1/4, isn't it? Then it's going to be, here it's going to be -1/2 plus 0 plus 1, isn't it? Because this is equal to 1. So the value of E of x in this case is going to be 1/2, 1/2. Then how do we calculate E of x squared? E of x squared is going to be -2 squared times the probability 1/4 plus 0 squared times the probability 1/2 plus 4 squared times the probability 1/4. So in this case, it's going to be negative 2 squared, which is 4, times a quarter, which is 1, plus 0, plus. Then in this case, 4 squared, which is 16, divided by 4, which is 4. So E of x squared is going to be 5. So having these values now, you know that variance is going to be E, as we said earlier on, E of x squared minus E of x, everything squared, which is what's our E of x squared? We said it's, wait, I think I made a mistake somewhere. Yeah, we'll see. Because I can see from how I calculated it initially and what I'm getting now. I think I made an error somehow, but let's see. Let me look for it now. Okay, it's here. Oh, actually, it's correct. Sorry. It's going to be E of x squared, which is 5, minus, what's our E of x? 1 over 2 squared. So it's going to be 5 minus, what's 1 over 2 squared? It's 1 over 4. So 5 minus 1 over 4 is going to be 4.75. That's how you get the variance. Any questions? Okay, I assume there's none. Now let's go on to question 4.2 is saying it's a probability density function. Keep that in mind. We'll use it later. Like we will use it later. Then question 1. Yeah, sorry, this thing just yeah. Share screen. Start. Just to confirm, can you see my screen?
Yeah.
So this is what you have. Then let's go on to question 1.6. So 1.5. Yeah, let's go on to question 1. Like what I can see is these questions are literally the same, because I feel like the moment we do this, I feel like question 1.5 should be the last where we do the table thingy, because it's like everything else is the same. So the moment you get a hold of this.
So because the questions are the same, can we like do maybe because we've done 2 of PMF, can we do 2 of PDF, and then let us do the rest, and then you can send us the answers so that we can really understand.
Okay, no problem. Thank you for the suggestion.
Of course, if that's okay with everyone else.
Yeah, I can hear from the rest. Like I feel like when you encounter a problem or a challenge, because the answers are already there, you see. So if you encounter a problem with any of the questions, you can just tell me, then I'll try to explain if I can. But I will explain either way. So now we've done the PDF, isn't it? We've done the PMF. Let's do the PDF one. So for the PDF one, let's do question 2.6. We'll do it at the end, because we have to explain a few things there. Question 4.2 also, please, we'll do it at the end, because there's a different thingy. So I want to look at which one did I do? It was 4.5, I think. Let me check. I did 4.2. Did I? Yeah, I did. Yeah, but it's actually easy. Okay, so let's do question 4.5. Question 4.5. So 4.5 is saying the total weight of fish caught by a professional blah 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 is a random variable x whose probability density function is. So if they say density function, then you're supposed to know that you're dealing with what? With a continuous. And when you're dealing with a continuous, the laws that apply to continuous variables are a bit different. And you see why continuous are okay, but what do you call this? You see the challenge actually. Let's just do them now. So the function is function of x is going to be equal to 1 over 148 into 7 minus 3x squared, of which the values of x are in between 2x and 6. And also, I want you to see something. You see all the examples that you are doing, like let's start with the first one that we did, this one. You see, like when they're telling you of the values of x, you are given exact values. Here you have -1, 0, and 4. And in the other question, we are also given the values of x where it's -2, 0, and 4. But with continuous now, it's not like the value is exact. It's in between 2 and 6. And it means that you can actually get a number which is 2.1. You can get a number which is 2.001, depending on the accuracy of your thingy. So that's the difference between the two classes of variables. So they are saying, what is the probability that the weight of fish that he catches on Tuesday next will exceed 5 tons? So now we are working for probability that x is definitely gonna exceed 5. So it's x is greater than what? Than 5, isn't it? But from what we have been told, or what we have been doing since like from counting methods up until now, we know that if x is greater than 5, of which we know that the values or the range of x is from 2 to 6, isn't it? So if someone says x is greater than 5, so the first thing that would definitely come to their mind is, okay, so if probability that x is equals to 5 is greater than 5, I mean, it's just probability that x is what? Is equal to 6. Since we know that the maximum value here is 6, isn't it? And we are working for probability that x is what? Is greater than 5, which makes sense, isn't it? But the only problem now is this only applies to discrete variables. Because for continuous, isn't it? They are saying probability that x is greater than 5. If you say probability like this is literally probability of x is equals to 6, it doesn't make sense, because since we are dealing with continuous variables, a value can take the value 5.23. 5.23 is also greater than what? Than 5. Like 5 is greater than 5, isn't it? But it won't be accounted for if you just substitute x is equals to 6. That's the only difference now between continuous and discrete. So let's assume you were told that your function is a PDF, isn't it? So it's a PMF, and you're given that the values that x can take, in this case, let's assume they said it's 2, 3, 4, 5, and 6. Like we're told that they're exact from 2 to 6 inclusive, then this would work, where you just calculate probability that x is equals to 6. But now you are dealing with a PDF, and what you have is a range rather than what? Like what you have is a range and not exact values. So how do you go about it now? This is what you do, as we did there. We know that whenever you're dealing with this, the first law that applies is integral function of x dx is equal to 1 for all x values, isn't it? So all this time we've been saying for all x values. So in this case, it means that the minimum x value that you have is 2, then the maximum x value that you have is what? Is 6. So it's going to be integration from 2 to 6 of function of x dx is going to be equal to 1. You see?
I don't know if it's my connection, but I can't see what you're writing.
Oh, okay. Let me try. Can you hear me now?
Yeah, I can hear you. I just can't see what you're writing. I don't know if it's my connection or.
Okay. Can you all see though? Can the others see?
I can see your screen.
Oh, okay. So I think it's a connection, but let me try to. Let me try to. Yeah, I think it is a connection. Can you see now?
Yes, I can now.
Okay. Okay.
Can you
So
just recap from the
okay.
part?
Okay. So here I was saying it's it's the integral of function of x dx incorporating all the values of x, isn't it? So by all values of x, it means that we know that the values that x can take from this thingy is from 2, and what's the maximum? The maximum is 6 of the function of x with respect to x is equal to 1. This is our first law when it comes to what? To random variables. So I'm just explaining this though I feel like in this example it's not gonna work. So here now they said, what is the probability that the total weight of fish that he catches on Tuesday next will exceed 5? So we're working out the probability that x is greater than 5, isn't it? So what is the probability that x is greater than 5? It's going to be the integral of our function of x dx, isn't it? But what are the limits? The limits in this case are from 5 to the maximum value that we have in our inequality, or in the values or the range of x. So it's going to be the integration, I mean, from 5 to 6 of our function dx. This is going to be equal to the probability that these guys are asking us about. Because here, keep in mind, we had said, let me use this. Here, this is the probability that you're working out, isn't it? Probability that x is greater than 5. So we want to incorporate all values that are between 5 and 6, you see. And why are we using 6 as our maximum? Because that's what we were told by this range of x. Like the range of x is definitely going to be equal to what? To, not the range, I mean, but the maximum value of x is definitely going to be equal to 6, you see. Of which they are asking us
Can you
for values.
can you please write in interval form so that like we can understand if x is just going to be greater than 5 and not equal to 5, and then smaller and equal to 6? Can you just please in an interval?
Okay, so when you're dealing with integration, thank you so much for explaining that. So the interval is, like, I'd actually forgotten about this. Let me do so. So when you're dealing with continuous variables, isn't it? Probability of 2 is less than or equal to x is less than or equal to 5 is the same as probability of x or whatsoever. Like whether or not it's inclusive, when you're dealing with continuous variables, it's the same. When you're integrating, you start from the lower bound, whether or not it's inclusive or not in the inequality.
Oh, okay.
Yeah. So when you're dealing with integration, please don't worry about that. Whether or not it's inclusive, like you can do whatsoever it is that you like, you can just integrate normally, because you don't care about whether or not it's inclusive. See. So we'd say that it's gonna be the integral from 5 to 6 of our function with respect to x, isn't it? This is equal to, I need space because our function is long. So using our function, it's going to be integral from 5 to 6 of 1 over 148 into 7 minus 3x squared with respect to x, isn't it? So when we're integrating, we factor out the constant, use integral from 5 to 6 of 7 minus 3x squared dx. And I'm sure a lot of you would have forgotten integration by now. And I really suggest that you revisit integration because you'll be integrating a lot from now onwards. Like integration is going to be, yeah, that pain thingy that you'll be dealing with. So here now it's going to be 148 into, so now when we're integrating this, it's going to be plus 1, which is 7 minus 3x to the power 3. Then you divide by the power, which is 3. Then here, it's going to be times what? The integral within the bracket, it's going to be negative 3. This is the integral. Then what are the limits of integration? We know we have 5 and 6. So what you do is going to 1 over 148. Since this is a constant, you can factor it out also, times negative 1 over 9.
Sorry, can I please ask?
Yeah.
You're saying we should divide by the integral inside the negative 3x.
Yeah.
But then when we integrate 3x, isn't it going to be
Oh,
3x
sorry.
squared?
Sorry, the derivative. Sorry.
Oh, okay.
Yeah, you'll be multiplying by the derivative.
Okay, cool.
Okay. So it's going to be that 10 into 7 minus 3x to the power 3. Isn't it? Then what are your limits? From 5 to 6. So if you do this now, it's going to be negative 1 over 148 times 9. This is the denominator. Then when you factor in these values, you factor in the value of 6 here. And I remember when I factored out the value of 6, it was negative. The answer that I got was negative 1,331. Then minus, when you factor in the value of 5, I got negative 512. So when you do this computation, obviously this value in the bracket is going to be negative, isn't it? Since it's negative plus, negative minus is going to be plus, but this value is greater than this one, so you get a positive. So it's going to be negative this plus that, then you get another negative value. So negative times this negative will be positive. And if you carry out this, if you have a calculator on you right now, times 9 into negative 1331 plus 512. If you do this computation, I got an answer of 0.61, which is similar to what's written in this document.
Sorry, where did the negative in front of 1 over 148 times 9 go?
Oh, sorry, it's here. It's there. So this negative is going to cut, since we are saying it's negative, this plus that, it's going to be this negative times this negative, then you get a positive. Do you see it?
Yeah.
Okay. So yeah, this is how you go about this question. Any question or anything of some sort?
Yeah, I wanted to ask, how would you approach it if the question said, the ton will not exceed, but in the weight will not exceed 4 tons. So now the 5 is included.
It will not exceed 4 tons. It will not, or it will exceed.
It will exceed 4 tons, yeah.
Oh, so if it's exceeding 4 tons, it's gonna be greater than 4, isn't it? So your lower bound will be 4, not 5.
Okay.
Then it's gonna be the same computation, but your lower bound of integration will be 4 now, because since you are working from 4 upwards.
Okay. All right.
So is the maximum always going to be the highest value of the interval?
Thank you so much for asking that. That's where I was going. So with this guy now, what he does is, like, let's assume for this question, isn't it? We have function of x, it's going to be 1 over, let's say 1 over 6 into 7 minus 3x squared. Like this is just an arbitrary function, you see. Then you are given that your values of x, isn't it? Like your values of x is going to be x is greater than 3 for all values of x greater than 3. You see, like let's assume this is the what do you call this? This is the limit that you are given, the interval, I mean. It's going to be x is greater than 3. Then they tell you, like, calculate the probability, like just as they said in this other question we did now. Like, find the probability that that the variable x, isn't it, will be greater than 2. You see. So in this case, isn't it? They are saying that the variable will be greater than 2, isn't it? So when you integrate this, like, can someone tell me, when you're integrating this, what is the value of your lower limit and what is the value of your upper limit? Like, you're given this question, they're saying x is greater than 2, but you're thinking me now, like the range of x is not given as a range as we did initially, but it's just given as x is greater than 3. Then how do you do it? What's the value for a lower limit? Lower limit is simple, but what about the upper limit now?
Is it not infinity?
Thank you. Your upper limit will be infinity, then your lower limit will be 2. So when you're integrating this now, you'll be integrating from 2 to infinity of the function of x dx. This is, yeah. So whenever you're not given a range which is specific, and if it's more or less like how I gave it here, like how I represented it here, you'll be dealing with infinity. So when you're dealing with infinity now, you also now have to revisit your maths, what I don't know what it's called, but yeah. But one thing that I can guarantee you is it normally gives these infinity questions whenever, like, let's assume you have integral, isn't it, or function of x. Let's assume from 0 to infinity of dx, isn't it? So when you integrate your function, let's assume that your function will be maybe an exponent e to the power negative x plus 3 or something, or maybe 1 over something or something of some sort, 1 over x, I think. Yeah, like 1 over x in particular. Such that whenever you substitute the value of infinity, you know that when you're given a function which is 1 over x, whenever x approaches infinity, your function will always approach what? Is it 0 or 1? Like, I don't know. You should try to revisit limits and stuff. So these are normally the two cases that it gives you see. So that you know that the exponent of a negative number will always approach. The exponent of a negative number should approach 0, if I'm not mistaken. Then 1 over x, as x tends to infinity, this will also approach 0. You see. So you also have to try to recall limits, because you will definitely give you such questions. Like, definitely, that much I can guarantee you. He won't give you the interval as it did here, but he will just tell you that it's just x is greater than a specific value. Then you have to look for whatever it is that you'll be looking for. Then that's it. I hope it makes sense. Then I'm looking for this particular question, but I can't find it. But let me try to model it myself, because I feel like it also comes, but okay. So you saw, as we did with our discrete random variables, Like you're given a function, isn't it? Like this one. What's going on? Okay. Like let's say you're given a function as this one. Like this function. And we wanted to calculate the value of k in the sense, then we did this and stuff, then we got it, isn't it? The same also applies to continuous random variables. So what it does is you're given a function, isn't it? Like let's assume function of x is equal to 1 over 148. Let me use this one that we did, k into 7 plus x. Like let's assume this is the function, isn't it? Then I'll try to give it in two, what do you call this? In two terms. Like the range of this function would be, let's assume it's 2 from x to 8, isn't it? Then he asks you, like, calculate the very same thing that we asked to calculate on the other question. But in this sense now, we don't have the value of k. So what you have to do is you have to calculate the value of k first before we dwell into any calculation of some sort. Then the question is, how do you calculate the value of k? You just do what we said we do. It's going to be the integral of OX, function of x dx. It's going to be equal to 1. So we said then the integral of the integral of our function within those limits is going to be equal to 1. And as the other person had asked, if the question is like this, or like this, your intervals don't change. Like integration is not that specific, you see. So these two values are just the same, like they're similar. So in this case now, it's going to be integration from 2 to 8 of our function, which is 1 over 148k into 7 plus x. It's going to be equal to 1. You see? Then you carry out integration. Like, I don't want to do it now because this is a question that I just formulated, you see. So the values that you might get might be wrong or something. But I'm just doing it as an illustration for you to know what to do whenever you're given such a question. So you calculate this, then you integrate, then you look for your value of k. Then when you have the value of k now, you can substitute it into the formula. Or let's assume when you do your computation, you figure out that the value of k is maybe let's say 7, isn't it? You found out that k is going to be equal to 7. So what you do now is you now rewrite the function. This function of x is going to be 1 over 148. Then instead of writing k, you just substitute the value of k that you would have gotten, times 7 into 7 plus x, blah, blah, blah. Then with the same conditions from 2 to x to 8. Then from this now, you can work out everything else that you would have been asked from there. Then you get your answer. Do you have any questions? Okay, I assume you don't. So with this, isn't it? Okay, you said we should do two of these. Then you can do the other ones. Let me look for question 4.4. But I'm actually not going to do it because it's actually the same as what you just did now. So question 4.4 is saying function of x. Like it's actually the same. It's just changed one or two things. Now actually it's the same. That's what we did. Yeah, because you can see question 4.4 is almost similar to question 4.5. Like it just changed the value of the constant and the range only. That's what it changed. The question is just the same. You work it out the same way that you just work this one out. Then that's it. Yeah, I feel like with this, we have explained. Oh, okay. Wait, let's go on to question 4.1. This is what I've been looking for. Question 4.1 it's saying the daily load carried by a 5-ton truck in tons is a random variable with probability density function. Whenever they say PDF, then you know that you're dealing with what? With continuous. And if it's continuous, what do? You know that you are implying what? Integration. The moment you know these fundamentals, I feel like everything will be fine. So it's saying function of x is given by k into 7 minus 2x squared, isn't it? Then where k is a constant whose value is. So they want us to calculate the value of what? Of k. Then the range that you are given is from 4x to 6. See? Then how do you go about it? The solution. The solution is going to be, so function of x is given as that. Then what do? We say it's going to be the integral of all x values and function of x dx is definitely going to be equal to 1. See? Then we know that it's going to be k integral from 4 to 6 of k into 7 minus 2x squared. It's going to be equal to 1. I look for my calculator. Yeah, so we have this. Then we can factor out k. Then we integrate from 4 to 6. We get 7 minus 2x squared. It's going to be equal to 1. Then on integrating, we know that k is outside. Then when we integrate this, it's going to be 7 minus 2x to the power 3 divided by 3, then times the derivative of the function within the bracket, which is times -2. It's going to be 1. Like my integration can be wrong, though. Like, I don't remember the last time I did integration, but I'm just trying to recall. See, so bear with me if I make a mistake somehow. So it's going to be this. So it's going to be k. Then, we actually know our limits. It's going to be from 4 to 6. So it's going to be k times divided by -6 into 7 minus 2x everything to the power 3 with our limits as, actually this is not how you write limits. Like, my notation is always wrong. I don't know why. And 7 to the power 3, then your limits are going to be from 4 to 6. It's going to be equal to 1. So when you substitute 6, it's going to be -k over 6. When you substitute 6, the answer you get is going to be 7 minus 2 into 6 to the power 3. I got -125. Then it's minus, when you substitute the lower limit, minus 2. Then it's 4. That to the power 3. Wait, 7 minus 2. Then 4 to the power 3. It's going to be -1. So it's that minus 1. It's going to be equal to 1. So it's -k over 6 into -125 plus 1. It's going to be equal to 1. So it's -k over 6 into negative that. It's going to be -124. It's going to be equal to what? To 1. So this negative and this one cancel out. So it's going to be 124k over 6. It's going to be equal to 1. So k is going to be, let me check the answers that they got. It's going to be 6 over 124. This is the value of k, which is 6 divided by 124.
Can you please go up a bit? Where did the 6 come from? The k over 6.
It's part. Let me highlight it. This part. So it's 3 times 2, which is 6, and which is the denominator. Sorry?
Sorry, please repeat. You said it's 3 times?
3 times 2. Okay, let me do this the conventional way.
Oh, 3 times 2.
Yeah, because
Okay.
it's gonna be, isn't it, when you integrate, you divide by the new power, which is 3, then you multiply by the derivative, which is the derivative here. It's gonna be the derivative of negative 2x. So that's where it comes from. Unless if you want me to explain integration from scratch, but it's gonna be too long though and tedious, because I actually forgot some of the things, but I can do it though. But if you face any challenges, actually, let me just put it that way. If you face any challenges, integration related, you can tell me, then we can see what you can do.
Okay.
Okay. So yeah, now when you get this, your answer is 0.048387, which is 0.05, the one that you got.
Can you please go up one more time? I just want to take a screenshot. I didn't write everything. Thank you.
Okay. Okay, then with this, I feel like we are done with PDF and PMF. So let's do these ones now. Like, just to confirm, you guys haven't done a special discrete distributions, isn't like the likes of binomial, Poisson, blah blah blah. You haven't, isn't
No,
it?
we haven't.
Okay.
Yeah.
Sharp. So let me try to explain. Let's go on to question 2.6. Like, now we'll do question 2.6. We'll do question 2.3. Then we'll also do question 2.2. Yeah, like these question 2s, I feel like they were these component questions that are a bit long, and yeah, whatever. So question 2.6. Let's do 2.6. Question 2.6 is saying, is it, did I do it? I think I did. Yeah, I did. Okay. So question 2.6 is saying, a particular system in a space vehicle has 4 components. And these are A, B, C, and D, isn't it? Each component of the system operates independently of any other. The probabilities of the components working are: probability for A working is going to be 0.9, of B working 0.8, of C working 0.7, then of D working 0.5. These are probabilities of working. And what is the probability that at least 2 components will be working when the system undergoes inspection by 6 tomorrow? What are these people saying now? Wait, let me just. So, how is it 13 now? Okay, sorry guys, let me just send an audio to these people. Shit. The problem is I haven't been feeling well, you see, so I couldn't do any of the readings today. But I'll try to work on it tomorrow from morning until, like, I'll be working the whole day and night also, because I have no choice. Otherwise, I won't be able to write. But one thing that I know is by tomorrow I'll be feeling okay. So I'm really sorry for the inconvenience, but there was nothing that I could do. But nonetheless, I'll try to be as quick as possible. Like, I'll go through all the material tomorrow, then we'll discuss on Sunday the whole day. Okay, I'm sorry for that. Can you see my screen?
Yeah.
Yeah, Bo.
Okay. So we're doing question 2.6. Then it's saying, what is the probability that at least two components will be working when the system undergoes inspection at 6 a.m. tomorrow? So we're looking for the probability that at least two components will be working. Components. At least two components. Yeah, that's wrong. Okay. Two components will be working. So we know that we have 4 components, isn't it? And from the 4 components, they're saying at least 2 components will be working. So if it's at least 2 components will be working, it means 2, 3, or 4 components will be working, isn't it? So one thing that you already know is, what is the probability that all 4 components will be, no, actually, let's not do it that way. Let's do it the conventional way. What you do is, you can do it in either 2 ways. You can do it the long way, where you can calculate the probability of any 2 components working, then any 3 components working, then all 4 components working, isn't it? Or what you can do is, you can say, you can calculate the probability of none of the components working, then 1 component only working, and you can subtract this from 1, which is the total probability. So how do you go about these procedures? We know that you have 4 components, isn't it? A, B, C, and D. So let's do it this way now, where we are calculating this. So what is the probability of 2 components working? So for any 2 components working, we have, like, let's denote, like, I want to use a notation. So the notation that you'll be using, when A is working, let's say A, it's going to be A working, isn't it? Then A prime is going to be A not working. This also applies to B, C, and D. So whenever I say prime, then it's definitely going to mean that that component is not working. See, so the probability of 2 components working, we have A, B, C, and D, isn't it? So let's start with A. Let's say A is always working in this case. So if A is always working, so it's going to be A working, B working, C not working, D not working. The other combination, A, B, C, D. It's going to be A working and D working. So B and C will not be working. See, this is for any 2 components working. But for now, we are concerned with A only. Now let's go on to B. We have A, B, C, and D. If we say the combination of B and A working, we already have it here, so we can't include it. Then what about for B and C working? It's fine. So if B and C are working, then A and D are not working. Then for A, B, C, D, another combination, B and D will be working, so A and C will not be working. You see, this is the other combination. Then in this case, we're concerned about B. Now let's go on to C. A, B, C, D. We want A and C to be working. Do you have that combination? No, we don't. So B and D will not be working. Then A, B, C, and D. Do you have B and C working? Yes, we have it here. So C and D will be working. So if C and D are working, then these 2 won't be working. So the other one that you can get for A, B, C, and D, like, how many do we have? Like, if D is working, do you have A and D working? Yes, we have it here. Do you have B and D working? B and D working, we don't. No, we do. We do. We have it here. Do you have C and D working? We have it here. So meaning we are done for any 2 components working. Then for 3 components working, you do the same way. 3 components working is going to be A, B, C, D. So if 3 components are working, you have for when A, B, and C are working, then D is not. A, B, C, D. You have when A, B, and D are working, C is not. Then A, B, C, D, A, B, C, D. For when A, C, and D are working, B is not. For only B, C, and D working, then that's it. Then this is for, like, worked out for 2, worked out for 3. Then what about for 4? When all 4 components are working, it's just going to be A, B, C, and D. See, which is fine. So these, like, you can see how long these combinations are. So if you want to take it this route, it's going to be this long, but you can take the other route where we say that you subtract those 2 from 1. So now that I've written this, how now do you calculate them? It's actually straightforward. You say the probability of A working, we already have it as 0.9, then times probability of B working, we have it as 0.8, of C not working. Keep in mind, we are given probability of C working as 0.7. So what is the probability of C not working? It's going to be 1 minus 0.7, which is 0.3. Then times, what about of D not working? It's going to be 0.5. Because we know that probability of D working is 0.5. So if D not working, so it's going to be 1 minus 0.5, which is 0.5 also. So you do this for all these combinations, then you add the answers that you get. Then that's it. That's how you go about this question. Any question? Okay.
If we do the other method where you subtract the probability of the outcome being 1 working and 0 working, what is the total probability?
Yeah, like I feel like the main problem with that one is I'm really not sure if the probability is always going to be 1. You see, that's why I would like of us to go through this long conventional way, because you won't make a mistake.
Oh, all right.
But in most circumstances, it will actually be 1, like in most, but not in all, you see. So it's best to take the long route, but knowing very well that your answer is going to be what? Correct, you see. Any more questions? Okay, we did 2 points. Okay.
Can we not calculate this using counting methods?
If you want to, you can, but there's one problem now. You are given respective probabilities of working for all, like for the individual components. Because if you're given, let's assume they said the probability of working for all these components is the same. Like you see when you do the other question, where the probability of working of all the components is a single value, like it's the same, then you can use counting methods. But in this case now, considering that the probabilities are different, you can't use counting methods. It's going to be a bit difficult because the probabilities are not the same.
Oh, okay.
Yeah, so this is the only way that you
May I
can
please
go.
ask
The what?
what topic is this?
Well, it's random variables.
Oh, okay.
Yeah, it's random variables.
It's special something.
I think so.
Or is that the topic that we haven't done?
No, you have done it. Because the thing with him is, he is like whatever it is that he teaches, isn't it? You want you to apply what you know, because he won't teach you this in class. Like that's one thing that I'm certain of. Like you only see it in the exam and in the quizzes.
Because we've never done something like this in class.
Yeah, and I'm sure you won't. Unless if you ask him a question related to it, then yeah, maybe. Okay, let's go on to question. Just to answer the question that you just asked now on whether or not you can use counting methods, let's go on to question 2.3. Question 2.3 is saying a particular system in a vehicle has 5 components. Then each component of the system operates independently, and the probability of the component working is 0.9. So now you see what I was talking about. The probability of working is 0.9 of each component. So it literally means that, let's assume you have components A, B, C, D, and E. The probability of A working is 0.9, of B working, C, D, and E is 0.9 also. So if the probability is the same, then you can use counting methods. Like, it's actually going to be a bit easier for you to do so. So you have this. Then the system will be classified as in a malfunctioning state. So they're saying it will be malfunctioning. Malfunctioning if the number of components that are working are less than. So they're saying if the number of components that are working are less than the number of components that are not working. Then what is the probability that the system will be classified as malfunctioning? You see? So the question now is, how do you go about this? This is how you do it. We can have separate cases. We know that we have 5 components, isn't it? So if we have 5 components, if they're saying it will be malfunctioning if the number of working is less than not working. So let's assume we have 0 components that are working. Let me draw a table. We have this row column, for working, and this one for not working. So for working, how many do we have? Let's assume we have 0 that are working. We have 0 that are working. Then how many do you have that are not working? Obviously, it's going to be 5. This is the case, then obviously our system will be malfunctioning. Then if we have 1, then we will have 4. That's another malfunction. Then if we have 2 here, then we have 3. Then that's another malfunction. But we can't have 3 because the number of working will be greater than not working. So this will be wrong. So these are the only cases that we have. For when it's 0, 1, and 2 for working, and for not working, it's 5, 4, and 3. Then the question is, how do you go about this now? I want to do something. I'm sure it's not allowed though, but okay. So we have this. So let's calculate the probability of 0 working. And if 0 are working, then we know that 5 are what? Are not working. So with this one, isn't it? I don't want to work it out because it's a topic that you guys haven't done yet. But what I'll do is, you see this table that I just drew now. You use it. Like, this is just how you go about the computation. Like, I want to explain how you go about this. Like such a question, isn't it? Then you guys can try the method that I'm gonna tell you now. You can try it on this question and see if it's gonna work out. like I just wanted you to see this. Then we'll work on the other one, isn't the other question. Then I'll show you how exactly to go about, because the method that I used as I was going through this, isn't it? Like it's something that you do later when you're doing a special variables like the binomial and something. But I want to explain it using counting method terms. So if we do that, you will come back to this one now and you do it. Then if you get the answer or if you don't, you tell me, then we'll see what we can do. So just for explaining purposes, I just wanted you to see that this is how you formulate the question. Then as for working it out, let me do this other one, then you guys will try this one out. Let's go on to question 2.2 to be done. Now let's move on to question 2.2. Question 2.2 is actually the same, isn't it? But there's a catch or something that I'd want you guys to see. Let me see where I did it. Just to confirm before I start lying. Yes, this one, isn't it? The answer was 0. The answer I got was 0.92. You said it's question 2.2. Where's question 2.2? Yes, here's the question. So question 2.2 is saying a particular system in space has 5 components. The system must have at least 4, isn't it? It must have at least 4 working properly in order for it to gain re-entry into the atmosphere. So it's to gain re-entry into the atmosphere. Otherwise, it will not be possible for it to gain re-entry. Each component of the system operates independently of any other. And the probability of working, the probability of working is what? Is 0.9. Then, what is the probability that the system will gain re-entry? So, they're telling us that what is the probability that it will gain re-entry? But what is the condition for it to gain re-entry? We know that the probability should be greater than, the number of components that should be working should be at least 4, which is 4 or more, which is 4 or 5 actually. So it's going to be probability of X is greater than or equal to 4. This is what we'll be looking for, isn't it? So if we have what do you call this? If we have at least 4 components that are working, then this system will gain re-entry into the atmosphere. So how do you calculate this now? Probability that X is greater than or equal to 4 is just going to be equal to probability that X is equal to 4, which are working, plus probability that all the components will be working also. Keep in mind that, yes, this is possible because we are dealing with discrete random variables. The components working is an exact number. Like you can't be having 3.5 components working or 3.2, you see. So probability of X is greater than or equal to 4 is actually equal to probability of X is equal to 4 and or probability that X is equal to 5. See? So now the question is, how do you go about this? I'll explain it in counting method terms, then I'll show you the shortcut. The shortcut will make sense next week. I'm sorry, because that's when you would have done a special thing in this. So how do you go about it now? Solution using counting methods. Okay, we will say, isn't it the total number of components that we have is 5, isn't it? So if the total is 5, then if you are saying 4 are working, then probability of X is equal to 4. This means that it's going to be probability of 4 working. So it's going to be probability of 4 working and which is times probability of 1 not working. Isn't it? So what is the probability of 1 component working? Probability of 1 component working is what? Is what's going on? Okay. Probability of 1 component working is what? Is 0.9. Like we already know it. So if 0.9 is the probability of 1 component working, then what is the probability of 4 components working? We use the multiplication principle. Because it's going to be this component and the other one and the other one and the other one. And I remember if you are attending my classes prior on, I was always telling you that and means intersection and intersection means multiplication. So it's going to be 0.9 times 0.9 times 0.9 times 0.9, which is just 0.9 to the power 4. Isn't it? This is for 4 components working. You see? Then times what is the probability of 1 component not working? 1 component not working is going to be what? 0.1. Isn't it? That's fine. So this is how you compute the first part of it. But now I feel like this is a bit what do you call this? Like it's a bit like it's missing something. But there's something now. We say 4 components are working, isn't it? But how do we know which of the 4, like we have 5 components, isn't it? So amongst the 5 components, we want 4, like we want to choose 4 of the components that will be working, isn't it? So how do you go about this now? That's when you account for it, for counting methods. So you have 5 components that are working. So the 5 components, like the total sample space. Then how many components do you want to choose that are working? Obviously, you want to choose 4, isn't it? Then times the probability of 4 components working, which is 0.9 to the power 4, then times the probability of 1 component not working, it's 0.1. So this is how you go about probability of x is equal to 4. Then for probability of x is equal to 5, it's just going to be the same also. If x is equal to 5, then it means that 5 components are what? 5 components are working. So if 5 components are working, it means that none are not working. So if 5 are working, then how many components do we have in our sample space? We have 5. Then how many do you want to choose? You want to choose 5. Then what is the probability of all 5 components working? It's going to be 0.9 to the power 5. Then you add these 2 values. And when you add them, I got 0.92. Any questions?
Why are we adding the 2 probabilities?
Because here we say probability of x is greater than 4, greater than or equal to 4 is probability of x is equals to 4 plus probability that x is equals to 5.
Okay, I understand.
Okay. So this, everything that we have done now is actually what they call a binomial distribution. Like you remember me saying this when you do it. A binomial distribution, like the formula of it is going to be n choose r times the probability of success. Oh, this guy doesn't use p. I always had a problem with them when I did this course. Like our convention, like I feel like you see it when we do these things. Like our conventions will be a bit different, but either way, it will be one and the same thing. This guy uses theta. So theta is the probability of success. It's n choose r p to the r, then q, which is 1 minus theta to the power n minus r. This is what we call a binomial distribution. I don't want to explain it though, but yeah. You can actually, if you had done a binomial distribution, you would have gotten this answer straightforward using this. Because that's what I did, you see. Like I did this using a binomial distribution, but now it's like it doesn't make sense for me to actually try to explain binomial since you haven't done it. So I will try to do it, like I tried doing it with counting methods and I got this. So what it means now is you also come here, like to this question that we said you're supposed to do it. We know that the probability of working is 0.9, isn't it? The probability of not working is 5. So what you should do is for the first row, it's going to be 0 working, isn't it? So if 0 are working, then 5 are definitely what? Not working. Then 1 is working, then 4 are not. 2 are working, 3 are not. So you definitely choose, as we did here, like let's assume for the first one, you have a sample space of 5. So it's going to be 5, choose 0 for the ones that are not what? That are working, isn't it? Times the probability of working, which is I don't know what it is. Then for the ones that are not working within the same row, we have 5, isn't it? So you have 5 components and you want to choose 5 that are not working, then times the probability of not working. Then you get it, then you move. I'm not sure if it makes sense. 5 choose 3. Yeah, it's only the same thing actually. So yeah, that's how you go about this one. So you can try this one out. Then if you have any questions or anything of some sort, you ask me, then I'll try to address them. Then question 2.5 is actually what we did initially. Then question 2.7 is what we did initially also. Question 2.1 is what we did initially also. Yeah. So I feel like we have actually covered these questions that you normally ask. So just apply the concepts that I tried explaining now. Then yeah, I feel like everything will be fine. Any questions?
It's not related to this, but we're having a rewrite for test 1. So I was hoping like you could create a memo for us for the test that we already wrote so that we can see our mistakes if you have the time to.
Hey, when are you writing it?
Yeah, said anything yet. So
okay. No, I will try to, because I feel like the only time that I'm gonna be free is next week after, because I'm writing my last exam on Thursday. So I'll only be free after Thursday. Because I'm writing on Monday,
okay.
then I'll also write on Thursday. Then from then I'll be done. Like I won't be doing anything else. So I'll only be focusing on stats and the other thing in it that I'm tutoring also. So yeah, I will try to make a memo out of it. Do you have the question paper though? Because I don't on my side.
Yes, I do. I'll just send it to you after this class.
No problem. Yeah, any more questions? Okay, so if you have any questions before the quiz tomorrow, please, you can send them through. I'll try to answer them if I'm free. Like if I'm free, because tomorrow I have other things that I'm supposed to attend to pertaining to my Monday's exam. But I'll try to make time for it because it won't take time either way. So yeah, if you have any more, if we don't have any more questions, then I feel like this is the end of today's session. And thank you so much for your attendance. I will see you next week.
Thank you.
Thank you.
Thank you.
Sharp.
Thank you.
Okay.